I'm Angela and I'll be one of your Swearword online guides.
So this is what I call a GRE Extra. So basically I didn't include the lessons because it's not absolutely essential for you, but I figured if you wanted to, you could look up this extra. It'll give you some extra practice combining, well, I guess that's why it's called an extra, right? It'll give you some practice combining the things we just talked about. So for example, a little bit of practice with algebra and a little bit of practice with basic geometry. So if you've seen lessons, maybe I think it's 3 and 4, then you're in pretty good shape for this. So let's try this out. Or even if you haven't, you should still be fine. Or a wannabe square. Okay. And then what I'll do is I'll just mark him off. And let's make the length of the sides of the square A plus B. That'll be the total length. So this part will be A, and this part will be B. Okay? And let's do the same thing here. Let's make this A, and let's make this B. Let's make this A, and let's make this B. And let's go ahead and make this A and B. So we just walk all the way around, but can everybody agree? Every side is A plus B, so this is definitely a square. Okay, and since this is a square, these are all right angles. Okay, no big deal. Then, since I marked the points where we have A and B, right? Why don't we go ahead and just connect the dots? So maybe I can connect this right here, and connect this. Ooh, sorry, the picture's a little bit off. Connect this, yeah, even worse, and connect this. Okay, well, you get the idea of what I'm trying to do. Okay. Now, I want to do one more thing, see if it's believable. My picture's a little bit off, but you can see that this kind of wants to be a right angle. Just like this wants to be a right angle, and so does this, and so does this. So let's show that's actually true. Okay? So let's go back for a second and look at this. And imagine we have this. We don't know what that angle is, right? Well, we definitely know you have some angle here. Since this angle is opposite the side A, let's call this alpha. And let's call this guy beta, because it's opposite B. Okay? And then look at what we have here. So we have this guy, right triangle, right? So 90 plus alpha plus beta. So again, 90 plus alpha plus beta. You know that's got to be 180, right? Because every triangle root adds up to 180, or the angles inside do anyway. Right? So if we simplify this, alpha plus beta is 90. So no big deal. But then let's look over here at this guy. Do you guys agree? This is a carbon copy, right? It's got a 90-degree angle here, so is this. This is length A and B, so is this, A and B. So these are carbon copy triangles. They're exactly the same, right? So that means, let's see again. Since A is opposite alpha, A must be opposite alpha, B must be opposite beta, right? And then look what we have. You've got a straight line. You know straight lines add up to 180. So again, you know everything adds up to 180. You know you've got alpha plus beta, plus this magic angle in here, that's going to add up to 180, right? And again, same strategy. You know alpha plus beta, we said before, adds up, or over here, sorry, adds up to 90. So these go out. Now you have this question mark equaling 90. Right, so one more time, since alpha and beta is 90, subtract 90 from the left, 90 from the right, you end up getting the question mark is 90. So this angle here really is 90 degrees. So that's 90. Same reasoning gets us, this is 90, this is 90, and this is 90. Do you guys agree? And since all of these triangles are the same, right? If this is A and this is B, we just need to name this guy. Let's call him C. Since this is A and this is B, this too must be C, and C, and C. Okay. So you can kind of see where I'm going with this exercise, right? A little bit of review of quick geometry, okay, from lesson 4. And then let's tie this all together, a little bit of practice with algebra, right? So let's try to figure this out. In fact, why don't we just get the area of the big square? The area of the big square is A plus B for this side times A plus B for this side. So it's A plus B squared. And this is one of our special patterns, right? So this has got to be A squared plus 2AB plus B squared. No big deal. Okay, now let's focus on the inside square. That's simple. That's just C times C. So that's C squared. Do you guys agree? Okay, so now let's do a piecemeal. So I know the entire area is this thing, right? And I know the area inside, which is what we just did, is C squared. Do you guys agree? Okay, so what we're going to do is compute the entire area 2 ways. Brute force is A squared plus 2AB plus B squared. Another way to do it is this plus the area of this, and this, obviously give you the area of the whole square, right? Okay, so let's go for that. Let's find the area of this triangle. Well, you remember that. The area of the triangle is 1/2 the base times the height. Here we'll take as the base A, well, either way. You can take the base as A and the height as B, or the base is B and the height is A. It doesn't make a difference. it's going to be 1/2 AB. Okay, everybody agree? But you have how many of these triangles? 1, 2, 3, 4. 4 triangles. So the total area of the triangles, right, has got to be 4 times 1/2 AB, or just 2AB. Okay. So area of all 4 triangles put together is 2AB. Okay, so no big deal. Now let's just collect all this work. So the total area is a squared plus 2ab plus b squared. But the total area is also inside square plus triangles around. So inside square we said was c squared. Triangles around we said sum to 2ab. Right? So these two equations should be the same. Okay, so no big deal. So let's put them together. So then we get a squared plus 2ab plus b squared, right? It's got to be. So this is direct from the outside. This is adding up the square plus the 4 triangles, right? So that's going to give us c squared plus 2ab. Okay. Do regular algebra, basic arithmetic, subtract the same from both sides. Those guys go away. Then we have what's left over. Well, I guess we have that a squared plus b squared is c squared. Okay. This is actually a very, very standard proof. A lot of people use it.
So guys, here comes your chance to actually try the problem. So what I would suggest is you pause this video, go back to doing the problem, and then start playing again, and we'll go over it together.
I'm going to do this as a problem so we can put together some of the skills we built up in lesson 3 and lesson 4. Okay? There are cleaner ways where you make it look all pretty and show it and so on, but that wasn't the point here. The point is this is like a baby quiz. I want you to work through this and see if you're comfortable with the manipulations. Okay. So, anyway, that is actually a valid proof for the Pythagorean theorem.
Didn't I tell you to pause? Go back to doing the problem.
So again, let's take a quick second to look at the overview of this problem. Remember, we set ourselves up with this rectangle, or square, my bad, I keep saying rectangle. So square is a special type of rectangle, right? Well, the length of each side is a plus b. And we computed it 2 different ways. One was we just computed this area straight out. So that's got to be a plus b squared. Okay. Another way we did it was we did exactly the same thing, but what we did was we picked these points in here and constructed this square on the inside, right? And the inside square basically had A, B, C, A, B, C, A, B, C, something like A, B, C. Okay, and we did, instead of doing it all at once, we did it piecemeal, right? So we said the area of the whole thing is the area of this guy, which is c squared, plus the areas of this, 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 and this. They're all identical. So it should be 4 times the area of one individual guy. But one individual guy is 1/2 base times height. So it should be 1/2 AB. Okay, so, and then, one more time, we set these equal, and you know how we finish the rest.
I'll see you next time.